My name's Martyn Davies and I work for Palomar Technologies based in the UK. We're located in the southwest of England at Epic Painton. It's a brand new facility, and Epic stands for the Electronics and Photonics Innovation Centre. It's an incubator unit with lots of SMEs. Our neighbours are other Epic members like Photonics and very exciting company Effect Photonics that are exploding at the moment. And we work closely together within the facility on lots of collaborative, innovative projects. And strategically, we're very happy to be positioned within the heart of the Torbay high-tech cluster. So we're all part of this exciting photonics world with its rapidly growing market. The fastest growth and greatest challenges, however, lie in silicon photonics. And as you can see from this chart, you know, 40% compound annual growth rate over, the next 5 years plus is really exciting. And that's made up of optical transceivers, data transceivers, the 5G rollout, 3D sensors and LiDAR, and really exciting for us as well is quantum technologies, to name a few. So if the demands for performance gains and efficiency are clear, the flip side of this coin is the challenging and packaging processes and machine capabilities that are required to squeeze large package functionality into smaller, more thermally efficient footprints. So the machine requirements necessary to meet these challenges include a perfect balance of throughput, placement accuracy, and repeatability across a large work area. At Palomar, we are continually adapting our 3880 model through hardware and software innovation to meet these criteria. These technical demands stretch across all stages of the concept to market spectrum, whether your product lifecycle is at research and development phase, maybe you're at new product introduction, or in volume production. The 3880 can be configured to meet all these capabilities required. Used for mass production across the globe, it's been adapted and tuned to provide a variety of bond options, material presentations, and automations of process, as you can see from this slide and the various layouts around the perimeter. So, combo bonding, utilizing multiple Palomar systems to solve next generation photonic packaging challenges. So Palomar solutions extend from die bonders to wire bonders and vacuum reflow systems as well. As a complete and integrated solution system, it provides for performance edge manufacturing and significant commercial advantage. For example, in this slide, you'll see our brand new 8100 ball bonder on the left-hand side. This has a very large work area, and I'd say the main advantage of this machine is it has a dual Z-axis. So the Z-axis moves in a true linear vertical motion and in the rotary motion as well. And what this combination of Z-axes allows you to produce very highly defined, very repeatable planar ball bumps. So for instance, for a PIC, photonic integrated circuit application, you can put these very highly accurately bonded ball bumps down on the PIC surface, and then in combination with the 3880 die bonder, the materials can be presented to the machine, flipped, and thermocompression bonded to the substrate. So we see this as a major move in photonic transceiver design and development, and through this process, you'll really be able to squeeze the highest performance out of your product. Likewise, you could in your thermoelectric cooler attach process, you could utilize the 3880 die bonder for both the tech and the chip-on carrier tack bond. So you could position it, take it up to temperature just to hold it in place at 5 microns, and then downstream you could use the SST vacuum reflow system to get that void-free eutectic interface, really again to squeeze the very best thermal performance out of your package, which is so important these days. So challenges, looking ahead, what further challenges do we see? Well, there's the relentless drive to miniaturization, the increased PIC structure complexity, meaning more delicate keep-off areas. So, for considerations for die bond tooling, complex waveguides, air bridges, greater optical alignment automation, the move away from expensive hermetically sealed packages, perhaps in some markets. Increasing diversity of sourcing through ever-changing supply chains. So, sourcing substrates and gold boxes from multiple vendors, where there's going to be surface reflectivity differences, fiducial differences, surface energy differences, and then when you try and run multiple supplied parts down your production line, it can cause some real problems. So we're aware of all these issues. And all of these factors reduce the process window, which negatively affect the first pass yield, and then results in an ever-growing scrap pile, which is very expensive for photonics companies. So one solution I've been working on here at Epic Painting, when using low mechanical strength UV epoxy for UV epoxy bonding optical components, we've introduced in situ plasma cleaner. So compared to batch plasma cleaning, what you can ensure is for every beam splitter, Palomar lens that you put down, every single time you're going to have a very, repeatable, uniform bond shear strength. And this is really important for the optical chain for passive optics placement within transceiver products. If you batch plasma clean, by the end of the shift, they're contaminated again, and you really lose that mill standard and lose your yield. So that's something we've been working on. So a vital part in achieving these successful innovations is working with the knowledge of the customer, which Palomar does especially well through our global innovation centers. So we're strategically positioned throughout the world, offering design for manufacture and assembly, rapid prototyping, process development, and contract assembly services. And that's available in Carlsbad in California, in our Singapore office, and now in the UK for everyone to make use of. Through these experiences, in terms of the transceiver world, we're acutely aware of failure modes like shear hysteresis when eutectic bonding laser diodes, epoxy bleed out ruining wire bond processes. I just mentioned the UV bonding and using low strength UV epoxies, and also improving the tech thermal efficiency through combo bonding. So with this knowledge, Palomar, we can align our R&D vectors to meet these customer challenges head on. So I'm based here in Painton in the Electronics and Photonics Innovation Center. It's a brand new facility. It's well equipped, and we're adding additional capabilities all the time. So about 2 weeks ago, through collaboration with Bay Photonics and Epic, they've managed to organize a pyramid lidder, resistive seam sealer, to come in together with the gross and fine leak testing. And I'm currently working on relocating an SST 5100 vacuum reflow system from the Manufacturing Technology Center in Coventry, and moving it into Epic within the next few weeks. And that means all tenants, all cluster companies can enjoy void-free eutectic bonding if they require, and also take advantage of this combo bonding that we're promoting. A couple of months ago, we did a live event, Epic at Epic, and you can check this on YouTube to find out more about the facility, our capabilities, and the tenants that we collaborate with on a daily basis. So please search for us during the conference and reach out with your questions and interesting challenges. We'd be honored to work with you. So it's Palomar Technologies in the exhibitor search, and myself and Dr. Anthony O'Sullivan are here to answer questions, network, and learn more about your requirements. Any questions, please send them to mdavies@bonders.com. And when it's safe to do so, when COVID restrictions are lifted, please come and visit us at the English Riviera. Bring the family, make a holiday of it, and we look forward to meeting you.